Alright, today in class we learned how to work with recursive and explicit formulas. So the first thing you're going to do is use a recursive formula to list terms in a sequence. And then after that we'll practice writing recursive and explicit formulas for both geometric or arithmetic sequences. An explicit formula allows you to find any term of a sequence by using a formula written in terms of n. So an example of an explicit formula would be a sub n equals 2n. So if we wanted to find any term, for example, if we wanted to find the 10th term, we would take 2 times 10, and that would give us 20. Or if we wanted to find the 50th term, we would take 2 times 50, and that would give us 100. So it allows us to find any term by using that formula. So if we wanted to find the 5th term, we would put 5 in for n, and that would give us 2 times 5, which is 10. A recursive formula allows you to find the nth term of a sequence by performing operations, so add, subtract, multiply, divide, to one or more of the preceding terms. So we're going to use terms that occur to find the next term. So I have this right here. What will happen with a recursive formula is it will always tell you what your first term is, or it'll give you a term in the sequence and ask you to find terms from there. So here it gives us the first term, and then it has a formula to find the second term. This formula says that if we are looking for the second term, that's the a sub 2, you have to take your first term, your a sub 1, and add 2. So we replace this a sub 1 with that 2, that's where that number comes from. Add 2 to it to get 4. So our a sub 2 is 4. We do the same thing, or same idea, to get the next term. So to get the a sub 3, we take this a sub 2 here, and we replace it, add 2 to it, and end up with 6. So your a sub 3 is 6. To find your a sub 4, you have to take the previous term, which was 6, replace it, and add 2 to it, and you get 8. So we get 8 here. So you can look at our sequence. It would be 2, 4, 6, 8. And you can tell that all we're doing to each term is adding 2. And that's where that part of the formula comes in. We add 2 to this term to get to 4, add 2 to 4 to get to the 6, and add 2 to the 6 to get to the 8. So our recursive formula would then, for this sequence, would then look like this. It always defines what your first term is, then it gives you a formula to find the next term. As long as you know the first term, you'll be looking for the second term. And this tells you about what domain you need to have. If you've already found the first term, then you're going to be looking for that second term. So n has to be greater than or equal to your second term. Example 1 asks you to find the first 5 terms of the sequence. So one thing you do know is that your a sub 1 right here is negative 2. We're going to use that information and apply the formula that is given. So we use that formula. Instead of finding a sub n, we're going to find a sub 2. So we're replacing that little n with the 2. So then this will take negative 3 times a to the 2 minus 1, and 2 minus 1 is a sub 1, and we know that a sub 1 is negative 2. So I'm going to replace all that with negative 2 and add 4. So when I take negative 3 times negative 2, it's 6 plus 4 is 10. Then to find a sub 3, you'll take negative 3 from the formula, and a sub 3 minus 1, which is 2, and a sub 2 is 10. So we're going to replace that with the 10, add 4, so you have negative 30 plus 4 is negative 26. And then to find the next term after that, we would take negative 3 times a to the 4 minus 1. 4 minus 1 is 3. And we know that a sub 3 is this negative 26 here. So we replace all of that with the negative 26, add 4 to get 82, and then to get your a sub 5, you take negative 3 times your a to the 5 minus 1, which is 4, and you're going to use that previous term, that 82, and replace that a sub 4 with an 82, and add 4, and you get negative 242. So we would say the first 5 terms of this sequence are negative 2, 10, negative 26, 82, and negative 242, and you have just used a recursive formula to list out the terms in your sequence, or at least the first 5 terms in your sequence. B is another example. So we start out knowing that a sub 1 is 7. So to find a sub 2, we're going to take that previous term, in this case it was a 7, and then following the formula add 12. So 7 plus 12 is 19. To find a sub 3, you're going to take that previous term, 19, and add 12 to it to get 31. A sub 4, you're going to do the same thing. We're going to take that previous term, not 31, but 31, plus 12 to get 43. And then to find your a sub 5, you take that previous term, add 12 to get 55. So we would say the first 5 terms in this sequence are 7, 19, 31, 43, and 55. Now you can see that each time to get to the next term we are adding 12. Each time adding 12 to get to the next term. So that would tell us that this is an arithmetic sequence. Okay, so our steps to writing a recursive formula. Our first step is to determine if the sequence is arithmetic or geometric by finding the common difference or common ratio. So you've got to identify that first. Your second step is to write the recursive formula. Our recursive formula for arithmetic is a sub n equals a sub n minus 1, our previous term, plus d. And that is your common difference, if you remember that. So you need to find d first. Or if it's geometric, you're going to have to find r, and r we will multiply by that a to the n minus 1. Once you have that identified and you have written those pieces, you'll state the first term. So you'll say a sub 1 equals whatever that is, and then you'll state the domain. And because we always say that first term here, you're going to say n has to be greater than 1, which is 2, or equal to 2. Your fourth step is you'll write the explicit formula. And we know these already. We've practiced them. This is your arithmetic that we spent a whole day doing. Your geometric, which we spent a whole day doing. Remember that this d here is the common difference, this r is the common ratio. A sub 1 is the first term in both sequences, and n is the nth term in both sequences that you're looking for. Example 2, you're going to write the explicit and recursive formula for each of the following sequences. So we're going to start out by finding the explicit. Before you can find the explicit, you have to determine if this is a geometric or an arithmetic sequence. Now you can see that this is going down each time by 4, so if it's going down, or if it's adding or subtracting, we know it's arithmetic. So if it's arithmetic, I know that we're finding d for the common difference, and this common difference is negative 4. So our explicit formula states that a sub n equals a sub 1, in this case it's 17, plus n minus 1 times d, and that's a times negative 4. So after this, we'll just simplify this, do a little algebra. We multiply by negative 4 to get negative 4n plus 4. Make sure you distribute that to both. And then you combine like terms, a sub n, and I like to put the 4 first, the n first, so negative 4n plus 21. And that is what your explicit formula will look like. Your geometric, or not geometric, your recursive. States that the first thing you have to do is find your a sub 1, or state your a sub 1. Our a sub 1 is 17. Then, to find the nth term, or our second term, here, to find our second term, if we started with 17, we would have to subtract 4 to get to 13. We're going to use that same idea. So if we're looking for n, we have to start with the term before n, which is your n minus 1, and subtract 4. So if we put a 17 right here, subtracted 4, that would get us our next term. And then after that, you have to state the domain. Because we started with our first term, we have to say that the domain, our n, has to be greater than or equal to 2. Okay, example 2, we're continuing. If you notice right here, we're getting big really fast, so it's probably by multiplication. And if it's by multiplication, we know it's geometric, and we'll be looking for r. So to find r, you can take 24 divided by 6 successive terms and divide them, and that gives us 4. And then we'll start with our explicit formula. This is what you guys did on your last assignment. Explicit says we take a sub n is equal to a sub 1, our 6, times, and I'm going to put this in parentheses, r, 4 to the n minus 1. And I put it in parentheses so you guys will remember that those two do not multiply. You have to apply the exponent first. And that's finished. There's nothing more we can do with that. So our recursive. Now remember that recursive requires that you state what your first term was. So our first term here, a sub 1, is equal to 6. And then we will go ahead and write our formula. Now, if you look at our series, we start with 6. What do we have to do to 6 to get to 24? We have to multiply by 4. So you're going to take 4, or that r value, and multiply by the previous term, which is a sub n minus 1. And that's all you have to do to that. And then you'll say what your domain is, and it has to be bigger than or equal to 2. And there's nothing else we do with that, so that is finished. On example 3, it's either going to give you the recursive formula and you will write the explicit, or vice versa, it will give you the explicit and you'll write the recursive. So before you do anything, you should identify, do you have a recursive or an explicit formula? Here you can see that it is explicit. So we will need to find the recursive. To find the recursive, you have to start out by identifying your first term. Now, we can't just look at this and determine our first term, so to do that, we're going to use this explicit equation. And I'll change colors. And we're going to find what our first term is. So what is a sub 1? So to find a sub 1, we put a 1 in for the n here, and a 1 in for the n there, and then add 3. So 6 times 1 is 6, plus 3 is 9. So we know that here our a sub 1 is 9. Then to continue on, we say our a sub n. To find the next term of our sequence, we're going to take a to the n minus 1 and do what? To figure out what we're going to do, we're going to come back to this equation, our explicit equation, and find out what a sub 2 is. So to find out what a sub 2 is, you have to take 6 times 2 and add 3. So that gives us 12 plus 3 is 15, and you can see to get from 9 to the 15, we are going to add 6. And because we're adding 6, this will tell you that it is arithmetic. So over here, we will add 6 and then state the domain. And our domain, because we started with our first term, n has to be greater than or equal to 2. Okay, example 3, we're doing the same thing. If what you want to do first is identify what you've been given, and this is a recursive formula. So we are going to go from the recursive to the explicit. And to be able to write the explicit, we have to know two formulas. Those two formulas, or sorry, not two formulas, two things. Those two things are a sub 1 and r. Well, a sub 1 we can get right here. And because we can see it's multiplying here, we know it's geometric, and that value is r. So we know that r is 0.8. So to write the explicit, we say a sub n equals a sub 1 times r to the n minus 1. And again, we cannot multiply those because of the exponent, so that is its simplified form. Your assignment is the recursive and explicit formulas worksheet. Good luck.